Hello, we are Team M. We are excited to work on this project. Our data comes from an energy survey taken in 1995 by the government. We plan to use it to help the world go green. We want to identify key features in the survey data that can help lower energy consumption. We can then predict whether a house will fall under a high or low energy consumption category. The predictions will not only allow the government to target eco-friendly campaigns to house buyers, but it will also help potential house owners save money on energy bills.
So our first step was to consolidate the various measures of gas consumption, electricity usage, etc. into a measure of total household energy consumption. Then we would look at the different features of each household to see which might predict high versus low energy consumption. And we had over 80 attributes from 3 different parts of the survey to look at. These were consolidated into a single data set after evaluating for data discrepancies, opportunities for consolidation and transformation, as well as high degrees of correlation so that we can remove redundancies in the input data, leaving us with 32 features to use in our model evaluation step.
We have pre-processed the dataset and eliminate the useless information. We expect to get results of a high-low class or a real value, so we need to think about what model to put in the box. To predict value, we decided to start from the simplest way, draw a line to make regression. We can tell the relationship between each feature and the output by easily comparing the multiplier. To predict the class, we have more choices. For example, decision tree is a very useful algorithm. We can make decisions for each step and finally reach different leaves which represent different classes. Also, those decisions that are closer to the root are the most important indicators we need to pay attention to. Above all, we use linear regression and CMU regression for prediction and classify high-low classes with decision tree, naive Bayes, k-nearest neighbors, and logistic regression.
Our model is required to recognize patterns for high energy consumption. This can be interpreted as a high recall, true positive rate for high class. Meanwhile, we want to reduce incorrect classifications by looking for low false positive rates and high precision for low classes. By comparing these 3 models, we found out logistic regression classifier has a better overall performance. We also applied other regression models to predict the numeric values of energy consumption, but the result is not so good. The coefficients provided by logistic regression reveals the importance of every feature. We concluded them in 3 categories. The most important one is regional factors. They directly affect the usage of heating and cooling. These attributes are usually stable and cannot be changed in the short term. House characteristics is the secondly most important factors. They will determine the capability of this house to reduce energy consumption and preserve the consumed energy. They are also stable attributes over long term. Last but not least, the activity index category will finally determine the actual energy consumption. These attributes are in short term and can be manually adjusted.
Now we have basically seen how the model is obtained, you must be curious about how could we benefit from the prediction. Let's say you are planning to buy a house in Pittsburgh. The real estate agent introduced you with 2 houses at similar price. You like both of them and feel difficult to make a decision. Then you can take our prediction model and house profiles to estimate the energy cost. Then life is easy and green. Another application might be that with our findings, government will be able to identify factors that discriminate between high and low energy consumers among the households. Being aware of that, supporting institutions can develop policies and solutions. Then they can influence the public by advertising practical ways of reducing energy consumption. The vision of the future is a green planet.
So what are the next steps? Well, first, we would like to build you some web applications. The first application will be for the government to use to identify high energy consuming households. The other will be for prospective homeowners to investigate energy costs before purchasing a house, similar to Google's Power Meter web application. In future iterations, we hope to collect more recent data with a higher temporal resolution, such as data including monthly or daily energy usage rates. Finally, we believe it is important to collect user feedback, evaluate new data against our current model, and design new features iteratively to maximize returns. Thanks for listening to our presentation.